Hello and welcome to KSS program's online lessons. Today we'll be covering Electric Circuit Theory lesson number 2, an introduction to electric circuits. Today's video is divided in 5 sections. First, circuit basics. Second, conductors and insulators. Third, circuit types. Fourth, safety review. And fifth, fun facts of the day. Let's begin with circuit basics. What are electric circuits? Let's recall from our previous lesson that current is electric charge in motion, and more specifically, it is the rate of flow of electrons, or negative charge. A circuit is the pathway that this negative charge can travel on. We can think of a circuit as a running track. The electrons, like runners, use the running track to get to their destination. Conductors and insulators. Remember from our last lesson that we use power sources like batteries and turbines to generate electric current? Just like the runners, the electric current likes to run. Now, not every surface or material is good for running, and the same goes for electric current. How can a runner run if they are floating in the air? Isn't it easier to run on pavement than on sand? This same idea is applied to electric current. Conductors. What are some popular conductors? A conductor is a material that allows energy like electric current to pass through it. Some materials are better than others for conducting. Electric circuits use conductors to allow electric current to travel. Copper, iron, gold, silver, aluminum, and mercury are some of the best conducting materials on Earth. Silver is one of the best conductors, but copper is more commonly used for being the cheaper material. Insulators. What are some popular insulators? Insulators are materials that work the opposite of conductors. They have properties such that they don't or hardly allow electric current to pass through. Similar to conductors, some materials are better insulators than others. Rubber, wood, glass, plastic, and air are excellent insulators. They allow no or very little current to pass through. Gases like oxygen, hydrogen, and nitrogen are also great insulators. Now let's analyze a simple light bulb circuit. This simple light bulb circuit consists of a battery for a power source, a copper wire as the conductor to allow electric current to travel, a switch to turn the circuit on or off, and the light bulb itself that shines when the current passes through. As seen on the graphic, switchers give us the option to switch on or off the light bulb circuit. The green arrows represent the flow of electric current when the switch is on. Now, in this case, like our example on the previous slide, current passes and light shines. When the switch is off, the copper wire is interrupted and electric current is not allowed to pass, so no light. Circuit types. Closed circuit. This is where electric current flows freely in a complete path. This is just like our switch on light bulb example. Open circuit. An open circuit is one where the electric current is halted. Open circuits with electric current terminating at a switch, it's safe, but open circuit where current is not safely terminated can be dangerous. This is like our switch off light bulb example. Short circuit. Short circuit is not desirable and usually done unintentionally. In this example, the switch is skipped over, and because current likes to take the path of least resistance, the switch will not work. We get short circuits when, for example, a loose wire connects to a part of a circuit that it was not intended to connect to. Short circuits can be extremely dangerous because current can build up at a place that the circuit designer did not plan for. This can cause damage or failure of circuit components. Series circuit. A series circuit is when the same electric current flows through all the circuit elements. This means that when the current is stopped, it is stopped for all the circuit components. Christmas lights are a great example of this situation, where if you remove one light, all the other lights in series after will not work. Parallel circuit. Parallel circuits are more common in what we have in our homes. We can think of a parallel circuit as branches of a tree where different branches can have more or less fruit hanging from it. Safety review. Stay safe and be cautious. Always, always, always ask your parents for help when using electronic equipment. Stay away from the water. Electricity loves water and travels quickly through it. Having electronics too close to water is extremely dangerous and should always be avoided. Do not plug too many electronics into the same outlet. It can cause you harm and damage to your home. If you see a power line on the ground, do not go near it. It can be alive and cause harm. Okay, to wrap it up, let's go over our fun facts of the day. Let us know if any questions. You can find us at info@kssprograms.com. See you next time.